Hello. In this video, I will be outlining my code for a Markowitz portfolio implemented in Python using a brokerage called Alpaca. And I'll also be doing a little demo of how this thing works. And so just for context, Markowitz was a person at University of Chicago who published a paper outlining how you can optimize a financial portfolio based off of the risk and return that you expect out of a set of assets. I know that might sound very complicated, but we won't really go into too many of the financial details. In essence, the idea is that we can look at historical data to get a sense of what kind of return we might expect from different stocks, how different stocks are correlated with each other, how risky each stock is, which means like how much variance might we expect in the returns of different stocks. And given all this information, we can essentially compute how much money in a financial portfolio we should allocate towards each stock. And so again, we're not going to really go into too many of the financial details, but essentially my idea is to use an online broker called Alpaca to obtain financial data and then essentially run this strategy on historical data and essentially test it out in order to determine how exactly we should implement this portfolio. And then once we've kind of figured out what are the optimal parameters that we can use for such a strategy, my idea is to implement the strategy using like fake money in my Alpaca account. And so without further ado, first I'll go into how I was able to test out the strategy based off of historical data and find the optimal parameters. And so I'm hoping that this will kind of make more and more sense as we kind of look through the code. And so first, just to set up, I've imported several libraries. Some of them are just to handle different files in Python. Some of them more to do some data analysis. The most important ones I would say are pandas, which we're going to be using to analyze the data, as well as Alpaca Trade API, which we'll be using to essentially use this broker, Alpaca's API, to not only get historical data, but also to place trades in our Alpaca account. And so essentially here I'm setting up my connection to the API, and then I'm going to go ahead and get historical data. So this portfolio that I'm going to be implementing is going to be looking at the 500 or so stocks that are in the S&P 500 index. So these are 500 of the top US stocks out there in the market. And so just to get a list of what these stocks are, I found something online that essentially lists a bunch of data about the 500 or so stocks in the S&P 500 index. And really all we care about is in this data frame is just the symbol column where we have the list of the different assets that we'll be needing. So I downloaded this. This is also available in my GitHub project folder or in my Google Drive. The details for how to access this is in my README in my GitHub project folder. And so essentially we can read in this data frame and then just look at the tickers that we get in this column, essentially the name of the different stocks that we'll be looking at. And from there, we can kind of use our Alpaca API in order to load in data from the past 2 years, from 2020 and 2021. And so we're essentially going to be using all this as our historical data. And in particular, we're going to be testing out our strategy on the 2021 year. So from January 1st, 2021 to December 31st, 2021. And so this is just me loading in data. Here I'm kind of reformatting things to only look at the close prices, which we'll be using in our analysis. And then also there's some issues that I saw in how Alpaca kind of has their data stored. For example, there's an occurrence called a stock split in which a stock's price might deviate very drastically without really any change in the company's value. And so really when this type of event happens, we should be adjusting the prices that we see before that date. And so what I did here, this is a little bit annoying to do, but I essentially went through all the different assets in our portfolio, used Alpaca to look for any sort of news announcements where the company announced that they would have this event, a stock split. And then when we do have an event such as this, I go back into my data frame and I adjust those prices accordingly. So this is kind of outlining the results of this. So we can see that, for example, on this date, the on this X date, August 2nd of 2021, General Electric stock essentially got multiplied by 8, by 8 over 1. And so essentially I'm going through here and updating this in my data frame. So now we have our prices, and then this is actually the function in which we're actually calculating portfolio weights. A lot of this is actually handled by another library called PyPFOpt, which you can see here. So essentially I'm loading in data, I'm kind of cleaning data and getting rid of values that might cause issues. And I'm just going to allocate 0 weight to any such assets. And I am kind of using this library to calculate what is the efficient way to allocate our money in our portfolio to these assets. And again, I don't really want to spend too much time dealing with the financial issues that arise, so I can focus on the Python aspects of this project. But essentially, I'm looking at the historical performance of the stock, the kind of variance and covariance that we see in the returns of the asset over time. And then from here, I'm able to essentially calculate what are the efficient weights. And again, this is kind of handled by this library on its own. And so then I kind of go through an example here. I won't spend too much time on the example so that we can actually look at the live strategy later. But essentially in this example, I'm looking at the past year of data in order to kind of calculate my weights on any given day. And I'm also going to be assigning 0.001 of my portfolio's value to any given asset. But I won't invest any more than 1/10 of my portfolio in any given asset. So these are just kind of constraints I'm placing on the weight calculation. And so, in this example, we can see that these are the weights that I have across 2021, shown by these columns over here on the right-hand side. Also, this is just to demonstrate by using percent change and shift, we can see our return for any day in this portfolio. And then we can also weight this by the amount of weight that we put into each one of the assets on any given day. And from here, we can see how the portfolio does and even graph this over time. So then what I want to do is look at Sharpe ratio. Sharpe ratio is what determines exactly how a portfolio is doing on a risk-adjusted return basis. So essentially, we're taking the expected returns for a given year divided by the standard deviation of returns for a given year. So again, to gloss over the financial stuff, the idea is that we want a very high Sharpe ratio in our strategy. The higher, the better, because we want to make money, but not be risking too much at the same time. And so in this example, we have a Sharpe ratio of 1.12. And then what I do is essentially I look at one parameter is our look back window, which is like how many days do we look back in order to kind of calculate weights for today's portfolio. And this ranges from 10 days to 200 days. And also looking at minimum weight, which goes from, I'm allowed to invest 0 in an asset to I have to invest at least 0.001 of my portfolio in any given asset. And also max weight. So this is saying either I can invest all of my money in the asset or I can't invest any more than 0.001 in an asset. So these are my different parameters that I have for my portfolio. And essentially this block of code here tries out all the strategy on 2021 for all the different combinations of parameters in order to determine the optimal parameters. And so from this, I actually got the optimal parameters of looking back 25 days, using a minimum weight of 0.001 and using a maximum weight of 0.1. So I've tested out my strategy on so many different parameter combinations, and I've come up with this as the ones that produce the best Sharpe ratio. So in this notebook, I'm actually implementing my strategy, not just in a pandas data frame, but actually in my Alpaca paper money account, right? And so here I have a function to use the past 25 days, get the past 25 days of data in order to calculate the weights for today. I have another function to use this historical data to calculate what portfolio weights I should be using today. And then I have another function to kind of determine how many shares of each asset I should be investing. And then I have some helper functions here just to wait till the appropriate times of the day to, place our different actions when we run our strategy. So just to kind of summarize things so far, we optimized our parameters for our strategy in our other notebook. And now using our optimal parameters that we've determined, I'm using this notebook to actually go into my Alpaca account and use my fake money to really run the strategy in real time. And so here I'm really just trying to go through and wait until the market opens, get the data that I need from historical data, calculate the appropriate weights, figure out how many shares I should buy. And then, an hour before the end of each day, I, sell all of my positions so that I'm just left with cash. And then 30 minutes before the end of the trading day, I invest all of this money according to the weights that I've calculated. And so we can kind of see what this looks like from today. So I ran the strategy and, the market opened, I got data, I got the weights, I printed out the weights. So we can kind of see what's going on here. Then I calculated the shares and I printed this out as well. And then finally, I, went through and purchased all of the assets I needed to. This is benign. It won't affect the performance of our strategy or our code. And so let's look at what happened in our actual Alpaca account. So we see that we've invested almost all of our money. Out of $10 million, we've invested all but 60,000 of it. And we can see that, we're invested in all 500 or so of these assets. And we can even see how the portfolio has gained and lost money over time. So, if we were to really go back and forth between these two tabs, we'd see that the portfolio is actually doing exactly what we intended to do based off of the shares that we calculated and the weights that we calculated. So overall, this was a very interesting project to work on. I've actually wanted to do something like this for many years now, and I just never had the time or motivation to do it. So this is a very nice opportunity for me to do so. And it was very interesting to see what are the trade-offs I made in terms of time, in terms of only using like daily data, for example, in order for my code to run efficiently, and also trying to use very simple code so that all the interactions with the Alpaca API would be safe and wouldn't be too sensible to bugs. So overall, I really hope this is interesting to watch, and I encourage you even try out my code on your own. And if it's profitable, put your money into it. Thank you.